So we said that it's useful to have a base shape, because then if I have a rectangle, if I have something that looks like a rectangle on my plane, so let's say if I have a class named rectangle, which is this piece right here, but once again, if I wanted to imagine what the rectangle might look like in memory as a set of integers, it really isn't that different from a circle, because for the rectangle, this could be, let me just draw a rectangle shape here on the side as an example. The x and y and the x2 and y2 in case of a rectangle could specify basically the 2 points that form the diagonal, right? At the same time, I may need other types of information, depends on how complex my drawing is, because if I wanted to also allow to rotate my shapes at the arbitrary angles, then x and y and x2 and y2 no longer would allow me to do something like that. I need to also provide some kind of another integer, perhaps specifying the rotation degree, right? So if I wanted to rotate, I don't know if this thing would only allows me like 90-degree rotations in this particular tool, but if I wanted to do the arbitrary types of rotations, then perhaps I would need another integer part of the rectangle, which would specify the rotation degree. At the same time, if I think about it, maybe a rotation degree could be stored with my base shape as well. So I have some choices between specific shapes and perhaps the base shape. So what is the difference between the base shape and a circle? What is the difference between the base shape and a rectangle? Well, perhaps base shape is a circle with a radius. Base shape, or let me put it this way, a circle is a base shape with a radius. A rectangle is a base shape with some additional coordinate information. So this makes sense to then say when we instantiate circles and rectangles and other shapes, what we do is that we keep the pieces of these objects kind of separate, right? So we say that x and y comes from the base shape, where for example, the rest of the information comes from a specific shape. So let's put this in code just to demonstrate this this type of arrangement. Let me just create a new project in NetBeans. So this will be my Java application, and I will store it here, and we will say this is perhaps week 4 of our semester. We can just name this project week 4, and yes, I will create the main class and say finish, which will create me an initial project with the main method in the main class, so I can save some space here, and so my idea is to be able to support shapes, and therefore I am going to say perhaps I should be able to say rectangle RR equals new rectangle, and maybe I can specify its initial points, such as coordinates 10, 20, and then 100, 200, right? So something like that could specify the creation of rectangle. But we said that it may be useful to maintain the base shape information versus the rectangle specific information in 2 different classes. So this is my project, and I have my package. So right here, I'm just going to say, what if I create new class, new Java class, and name it base shape? Okay, name it base shape, finish. Okay, so here's the base shape. And as we discussed, perhaps it would be useful in the base shape to store just one single point. In fact, we could have a helper object named point, but right now I'm just going to use integers. So private int x and private int y, and then I can say, all right, let me have a public constructor for this shape, base shape. Okay, and this is my constructor, and it's very simple. It will take x and y, int x and int y. It will take two integers, and then it will say, let's store x in this object, and likewise, let's store y also in this object. Okay, so very simple idea. For the sake of demonstration, I could also add another public method that's called, perhaps doesn't return any information, but it says move, right? And in my move method, what I can specify that I want to move my shape by a certain a certain number of units, and my units in 2D space are very likely to be pixels. So we'll just say int delta x and int delta y. And if I wanted to move my shape, what I would do is that I would say x equals or x plus equals dx and y equals dy. Plus equals dy, which increments x and y by the specified delta offsets. All right, so this is what I have in my base shape. So remember, base shape is something that I want to do use with more specific shapes. So in that case, if I already have x and y, which is part of my base shape, I can actually extend this class multiple times and say I also want to have a circle with some additional information, and I also want to have a rectangle with some additional information. Perhaps to make them look different, what I can do different here is that I can just say, instead of saying x and y, I can simply provide, instead, over here I could provide a radius. Like I said, circle is, from the computer standpoint, is like a base shape with the radius specified, because if I have those three integers, for instance, the position of the center of the circle, and then if I specify the size of the radius, very likely I should be able to make a drawing of it, right? Use the right trigonometry function calls. It's all about the right triangle computation, and quickly compute basically every point I need to draw on the outskirts of the circle and be able to draw it. Okay, so given this, how can I do this in software? In software, what I can do is I can say, let me create another class, and it's going to be named another Java class in the same package, and I will name it a circle. Right? And I can say finish. So here's my class in my package, and right here, this this class will have a private integer radius. I'll just use single r for it. And of course, to be able to initialize it, I need to say circle and create this public constructor for my circle, which will take an integer radius. But besides that, perhaps it's now I'm only half way done, because radius is not very helpful. I need to unite and connect my circle to my rectangle. I'm sorry, to the base shape. And therefore, this is what Java allows us to do. It says this class may be a subclass of the superclass named extends base shape. When we add this extends base shape, when we just add this to our to the definition of our class circle, what happens automatically that anytime we create a circle, what will happen is that this base shape will be made available to the circle, and the radius will be only added to the circle. And even so, we're not completely done with the circle definition, because guess what? The center should also be provided to the constructor. To be able to define a circle and use a constructor to initialize our object properly, we need both the coordinates of the center of the circle as well as the radius. So therefore, we can do what? We can say superclass, which is the base shape, right? Superclass. And we can call its own constructor that we know takes as x and y as parameters. Then we can also, of course, say this radius equals the parameter that was given to this constructor. So perhaps now this is more or less a properly configured circle. Of course, for all of these items like x and y coordinates and the radius, we could also add some getters and setters methods so that we can manage our shapes. But then, of course, there's also, if you recall, there is move. So if we want to move the circle around, perhaps it's enough only to move x and y. We really don't have to update the radius. The radius stays the same. Obviously, if you want to scale the circle and make it bigger or smaller, then we could provide a special method that manages the radius of the circle, making it larger or smaller. But that would be nothing to do with the move, right? So we have this type of situation where, once again, we define the base shape, we added x and y to it, and then we added a circle class, and we said that the circle actually extends, and we can basically draw an arrow like this to say that x and y is extending from the base shape. So this is where circle gets x and y, right? And also adds its own radius to the picture for the actual class. Okay, so let's